Welcome to Microsoft Build 2017. My name's Tommy Mullaney, and I'm on the engineering team for SQL Server here at Microsoft. In this video, we're going to talk about securing your application data using SQL Server 2017. Now, if you follow the news really at all over the last few years, you don't need to hear this from me. Data security today is more important than it ever has been before. The global cost of data breaches is estimated to rise to more than $2 trillion over the next few years, and organizations of all shapes and sizes are going to be impacted by this. And in fact, all the way up to corporate leadership, companies across the board are doubling down on their data security precautions and security measures. At the same time, data security is still perceived by most as being a real burden, something that's painful and difficult. And so it's with this context and this background that I want to leave you with this message today. SQL Server 2017 offers you a security tool set that enables you to fight these trends and to build more secure applications more easily than ever before. These security features are built in, they're easy to use, they require minimal, if any, changes to your application code, and they work across any programming language and any platform, whether that's Windows or Linux or Docker containers or public cloud or private cloud, you name it, it works everywhere. So how do we think about security for applications that use SQL Server? The way we think about security is in terms of layers. And at the center, of course, you have your data. And then the first layer of security is all about how you protect the data itself, typically by using some form of encryption. The next layer of security is about controlling access to the data through authentication and authorization, who has access to which parts of your data. Then the outer layer of security is about monitoring access and keeping track of who is doing what against your database. And so in this video, I want to briefly run through each of these different layers of security and show you how SQL Server provides you with the tools you need to secure each of these layers of your application. So let's start with protecting data, the first layer of security. There are three different encryption scenarios that I want to touch on here. The first one is what we call encryption at rest. And the idea here is, and this is a very common compliance requirement, the idea is that you want your data to be encrypted at rest so that if the data files or the disks on which the data resides are stolen by an attacker or some third party, all they're going to have access to is random gibberish ciphertext. And so SQL Server offers a feature called transparent data encryption that makes it very easy for you to encrypt your entire database at rest without requiring any changes to your application code, because the SQL Server database engine handles all the encryption and decryption as data is read from and written to disk. Backup encryption works similarly in that it allows you to encrypt data as you're taking backups. And cell-level encryption refers to the various T-SQL cryptographic functions that are built in to the T-SQL language that enable you to granularly encrypt individual cells or columns of data. So that's the encryption at rest scenario. The next encryption scenario is called encryption in transit. And the idea here is that you want to encrypt communications between your client application and your SQL Server so that a man in the middle isn't able to intercept those communications and eavesdrop or manipulate those packets. And there's a pretty standard industry solution here, and it's called the TLS 1.2 protocol. And I would highly encourage you to configure all of your applications to use TLS 1.2 when connecting to SQL Server. In fact, this is something that we do in our Microsoft Azure cloud across the board. So that's encryption in transit. The final encryption scenario that I want to talk about is one that I think personally is really cool, and that's called client-side encryption. And I want to dig into this one just a little bit more because it's so interesting. So the idea here is that I need to be able to store really sensitive data like like some social security numbers, date of birth, address, or other personally identifiable information. You know, exactly the kind of stuff that you don't want to get out in the event of a data breach. So it's highly sensitive data being stored inside SQL Server, but at the same time, I need to somehow prevent my high-privileged SQL Server sysadmins from being able to access that data. So traditionally, this is kind of a difficult problem to solve because if you're a SQL Server sysadmin, you kind of have the keys to the kingdom. You can access anything that's on that SQL Server instance. So of course, the solution is to encrypt the data before it even gets to the SQL Server instance. And this is where SQL Server 2016 introduced a really cool new feature called Always Encrypted. And what it does is it encrypts all of the data client-side using a master key that's stored outside of SQL Server that only the application has access to. So even though the data is stored inside SQL Server in encrypted form, your SQL Server admins don't have access to the key, and therefore they cannot access the plain text data. What's particularly cool about Always Encrypted is that our enhanced client drivers like ODBC or JDBC or ADO.NET, the same drivers that you're used to working with, these drivers handle all of the encryption and decryption for you so that your application code doesn't have to make all sorts of sweeping changes across your code base. The driver does all the grunt work and the hard work for you. And this winds up being a heck of a lot easier than the alternative options you have, which are either buy a third-party solution, which is expensive, or write some custom application code, which is both risky and expensive. So that's Always Encrypted in a nutshell, and I'm going to come back to this because I want to demo for you just how easy it is to get started with Always Encrypted using a simple application. Okay, so that's our first layer of security about protecting data. Jumping back to our diagram, the second layer of security is about controlling access to data. And the way we think about that with SQL Server is there's kind of two buckets of access control features. The first is what we call database access. And these are features that allow you to control who can access the data for people who can connect to the database directly. And this is where we have features like SQL authentication, Active Directory authentication, and a fine-grained permission system that allows you to configure least privileged accounts for your applications to run under. And this is one that I want to highlight in particular from an application security perspective. All of your applications should connect to SQL Server, specifying that account in the connection string, using a least privileged account, an account that has the minimum permissions required for it to do its job. And that way, even if your application code happens to have a SQL injection vulnerability somewhere, the amount of damage that an attacker can do is limited by the permissions that have been granted to that application service account. Okay, so that's the database access bucket of features. The other bucket of features here is what we call application access features. And that's where we have some cool stuff that showed up in SQL Server 2016. And the way these work is these are features that are kind of programmability features that let you define a policy within the database itself that controls what data is going to be returned to the application and ultimately exposed to end users of that application. And by centralizing that access logic within the database itself, you minimize the risk of error in your application code, and you also simplify your application code so that you don't need to worry about maybe you add a new application later that connects to the same data source. You want to have the same consistent access control policy always applied. So row-level security is one example of this type of feature where you define a policy within the database that says only these rows should be returned when this user is querying. Really useful for cases where you have perhaps a multi-tenant table or a table that stores data for multiple users and you want to filter which rows are returned based on the user's department or role or something along those lines. Dynamic data masking similarly lets you define a policy within the database attached to a column where you specify a masking function that will be applied so that whenever data is returned from that column to the application, that masking function is applied so that you only expose, for instance, the area code of a phone number or the last few digits of an account number. So these are useful features from a programmability standpoint. They help you simplify your application code. Okay, so that's the access control layer, that second layer of security. The third layer of security is what we call monitoring access. And the idea here is you want to be able to track what activities are happening against your database. And this is where SQL Server offers a feature called fine-grained audit. And the idea here is you want to be able to set up a policy within the database that says, I want to track these users doing these actions against these objects. And once you specify this policy, the SQL Server database engine will go ahead and log all activities according to that policy and write it all to a log file that you can use later on. This is similarly to transparent data encryption. This is a really common feature popularly used for compliance requirements where you need to have an audit trail. Okay, so that in a nutshell is how we think about security for SQL Server in terms of these layers, protecting data, controlling access, and then monitoring access. And one of the things I want to highlight here that's really, from my opinion, really great is that starting with SQL Server 2016 Service Pack 1, which was released in November 2016, a bunch of these features that used to only be available in Enterprise Edition are now available across all editions of SQL Server. And the idea here is that we want to provide a consistent programming surface area so that you can write your applications that use and leverage these security features and not have to worry about which edition of SQL Server is being used as the backend. So features like always encrypted, row-level security, dynamic data masking, and fine-grained audit, these are available across all editions of SQL Server, ranging from Express all the way up to Enterprise. Okay, so that's how we think about security with SQL Server. What I want to do now is I want to jump into a demo and show you just how easy it is to set up always encrypted, to encrypt some sensitive columns of data so that even my database sysadmins can't access the plain text. And this is just going to be one example of how easy it is to set up these features, but I think you'll find it illustrative. So with that, let's jump out of PowerPoint here and switch on over to our favorite Visual Studio Code. So here what I've done is I've downloaded a popular open source Django project called Boot Camp. And it's basically an open source enterprise social network application. And it's written in Python, uses the Django web app framework. It's a framework that I personally really like, which is why I chose it. And what you'll see here is if we jump on over into settings, you'll see my database connection string where I'm using the ODBC driver with PyODBC. And if we take a look at the host, I'm connecting to a SQL server that happens to be running on an Ubuntu machine. So I've got my application here, Django, Python, running on my Windows laptop, Windows 10 laptop, and it connects to a SQL server that's running on Ubuntu 16.04. I could configure this really any way I want. The operating system and the programming languages don't really matter, but this will demonstrate just how it works with one of these configurations. Okay, so just to give you an idea of what this looks like, let's go ahead and run it. We hit Manage, Run Server. We'll give it a moment to load. Okay, cool. So the application is running. Let's jump on over into Edge and refresh our local host. Okay, so this is what Boot Camp looks like. It's a pretty standard social network looking site with a feed, articles, network, that kind of stuff. There's a whole bunch of functionality here, but what I want to focus on is if we jump on over into account settings, you'll see my profile information. And this is information that's perhaps a little sensitive. It's certainly okay for me to see it because it is, after all, my information. But maybe we don't want our SQL Server sysadmins to be able to access the job title information or the location information for all of the different users of this application. So this is a perfect use case for always encrypted, where we can use it to transparently encrypt these values before they're sent to SQL Server and then transparently decrypt them as they come back to our application code. Okay. So to enable always encrypted, the easiest way is to jump on over into SQL Server Management Studio, where I've connected here to my Ubuntu SQL Server. And I have my Django database. Just to show you the operating system that this thing is running on, let me do a quick select. Run this guy. And you can see that this is running on Linux, Ubuntu 16.04. Okay. So the table that I want to look at is called auth profile. And if we select from this, you'll see there's the location and the job title information that I was just looking at through the front end. So these are the columns that we want to go ahead and encrypt. So to do that, let's hop over into the Object Explorer. I'm going to go find that table. And here it is, auth profile. And if I right click on that and select encrypt columns, this is going to bring up the always encrypted wizard. And if I go ahead and hit next, now it prompts me to select which columns do I want to encrypt. I'm going to choose the location and job title columns. And now I have a choice. What type of encryption do I want to use? Here, I'm going to choose randomized encryption because that offers maximum security. The other option is called deterministic encryption. And what's interesting about deterministic encryption is that whenever you give it, the algorithm, the same plain text, you're always going to get the same ciphertext. And this allows you to do certain types of operations like lookups, equality joins, or indexes on these columns. But at the same time, if your columns only have a few different possible values, sysadmin might be able to see patterns in the ciphertext that reveals some kind of information. So we're going to go with randomized because I don't need to do any lookups on these columns here. Okay, so I hit next, and this is the interesting thing. We're going to automatically generate that master key that I mentioned that's going to be stored in the Windows certificate store where my client application, this Django app, is running. It's not going to be stored on the SQL Server instance. And in fact, someone with total control over that SQL Server instance will never have access to this key, and they'll never be able to access that plain text data because they won't be able to decrypt it using this key. Okay, let's hit next, and we'll say finish now. We'll run it. And so this wizard is going to go ahead and generate that master key, generate a symmetric key to do the encryption operations, and it's going to go ahead and actually encrypt that column of data, or those two columns of data. We'll let it run and finish up here. Okay, there we go. So let's go ahead and close this. And just to show you the results of what we just did, let's go ahead and run that same query again. And what you'll see is that now the location and job title fields are encrypted. Okay, cool. What about our application though? If we switch back over to our application and hit refresh, you'll see that there's an error. There's a type error. And this is where there's one small change that we need to make to our application code to make this work. If we switch on over into Visual Studio, I'm going to add one parameter to our connection string that says column encryption is enabled. And what this does is it tells the ODBC driver to be always encrypted enabled, to be aware of columns that should be encrypted and decrypted by the driver. So we'll go ahead and do that. We'll hit save, and we'll let Visual Studio Code go ahead and refresh our application. And if we switch back over to our application here, we hit refresh, and there you go. Those columns, job title and location, are now being transparently decrypted before they're returned to our application code. We didn't have to make any changes to the queries or anything like that. It just worked. So in summary, SQL Server 2017 gives you an enterprise-grade security tool set to build secure applications more easily than ever before. We walked through the different layers of security that SQL Server helps you protect, protecting data, controlling access, and monitoring access. And we walked through all the different security features that are available to you that are built in, easy to use, require minimal, if any, changes to your application code, and can run with any programming language on any platform and in any edition of SQL Server. So with that, what's next? If you're just getting started with SQL Server, I'd highly encourage you to take a look at our Developer Getting Started tutorials. These tutorials will walk you through in just a matter of minutes how to get started building an application with SQL Server using your favorite programming language. If you already have a workload ready and you want to get it going in production on SQL Server 2017, I would encourage you to check out our early adoption program where you can sign up here. And through this program, you'll be able to work with someone on the product team like myself, and we'll help you get up and running with SQL Server 2017, and we'll offer you full production support for your workload when it's ready. And if you're looking to learn more about the security capabilities of SQL Server 2017, I'd highly encourage you to check out our SQL Server Security Center. This is kind of a hub that we've put together that stores all the different information, getting started tutorials, documentation pages for all of the different security features that I walked through in this video today. And it's a perfect place to start off with if you're looking to learn more about the things we talked about in this video. So with that, thank you very much for watching, and I'll look forward to hearing about your feedback on the security capabilities of SQL Server 2017.